Hello students, I am Dilip Udanu, Assistant Professor at LJ Institute of Engineering and Technology. Today, I will teach you a new unit, that is Fourier series. So first of all, we will see actually what is Fourier series. So with the help of Fourier series, we can expand periodic function as infinite sum of sine and cosine. And today's topic in Fourier series is Fourier series of functions of period 2L. So let's start. So first of all, we will see Dirichlet's condition for representation by a Fourier series. So what are the Dirichlet's conditions? So with the help of Dirichlet's conditions, we can see whether the Fourier series of the given function will exist or not. The Fourier series of the function fx exists only if the following conditions are satisfied. The condition number 1 is fx is periodic. Now, what is the meaning of a periodic function? If for function of x we have f of x equals to f of x plus 2l, where 2l is the period of function of x, then we will say that function of x is a periodic function. So the first condition is the function must be periodic. Then and then only we can find out its Fourier series. And the second condition is f of x and its integral are finite and single values. The function of x and its integration should be a finite value and it should be a single value. Then after, the third condition is f of x has a finite number of discontinuities. And what is the meaning of this one? That is, f of x is piecewise continuous in the interval c to c plus 2l. Condition number 4 is f of x has a finite number of maxima and minima. These conditions are known as Dirichlet conditions. Now we will see how to find out the Fourier series of functions of period 2L. Let f of x is a periodic function with period 2L in the interval c to c plus 2L. Then the Fourier series of f of x is given by f of x equals to a0 by 2 plus sigma from n equals to 1 to infinite an cos n pi x by l plus sigma n is from 1 to infinite bn sin n pi x by l, where a0 is 1 upon l integration from c to c plus 2l f of x dx. An is 1 upon l integration from c to c plus 2l f of x cosine of n pi x by l dx, and b of l, that is equals to 1 upon l integration from c to c plus 2l f of x sine n pi x by l dx. So this is the formula, right, with the help of which we can find out the Fourier series of a periodic function of f of x in the interval c to c plus 2l. Now we will see example number 1 related to this topic, that is, find the Fourier series of function of x equals to x square in the interval 0 to 2 pi, and hence deduce that pi square by 12 equals to 1 upon 1 square minus 1 upon 2 square plus 1 upon 3 square and so on. So comparing 0 to 2 pi with 0 to 2l. So we have 2l equals to 2 pi, so definitely the value of l is pi. The Fourier series of function of x with period 2l is given by f of x equals to a0 by 2 plus sigma n is 1 to infinite an cos n pi x by l plus sigma n is 1 to infinite dn sin n pi x by l. Now first of all, what we have to do here, we have to replace L by pi. If we replace L by pi, we have a0 by 2 plus sigma n is from 1 to infinite an. If you will put down the value of L equals to pi over here, so pi will cancel out, so we have cos nx plus sigma n is from 1 to infinite dn. Similarly, sin n pi x by pi, so we have sin nx. Now we will find out the value of a0, an and dn. So a0, that is 1 over L integration from c to c plus 2l f of x dx. Here as you can see that the interval is 0 to 2 pi, so we will put down the value of c equals to 0, so it will become 0 to 2l and the value of L is 5. So we have a0, that is equals to 1 over pi, as the value of L is pi. Integration from, we will take c equals to 0. So 0 plus 2 into value of L is pi, so it is 2 pi. So integration from 0 to 2 pi, and f of x is x square dx. Now we will integrate x square with respect to x. Now all of you know that integration of x raised to n is x raised to n plus 1 over n plus 1. So integration of x square is x cubed by 3. So 1 upon pi will be as it is, and integration of x square is x cubed by 3, and the limit is from 0 to 2 pi. So first of all, we will put upper limit 2 pi and then after lower limit 3. So for upper limit, so it will become 2 pi the whole raised to 3, so it is 8 pi cube, and then after minus 0 raised to 3, so it is 0, and 1 upon 3 pi will be as it is. Now we will simplify this result. So we have 8 pi squared by 3. So this is the value of a0. Now we will find out an, and an equals to 1 over L integration from c to c plus 2l fx cos n pi x by dx. Here we will put down the value of c equals to 0 and L equals to pi, and f of x equals to x square. So we have an equals to 1 over pi integration from 0 to 2 pi f of x replacing L by pi, so we have cos nx dx. Now we replace fx by x square, so it is 1 over pi integration from 0 to 2 pi x square cos nx dx. Now we will integrate this function x square cos nx dx using Bernoulli's formula. So you can see that 1 upon pi will be as it is. Now what is Bernoulli formula? First of all, you have to write down the function x square as it is. Now find out its derivative and write down over here. So derivative of x square is 2x. Then after again find out the derivative of 2x. So 2 will be as it is, and derivative of x is 1. Okay. Then after you have to integrate cos nx, and integration of cos nx is sin nx by n. Then after you have to integrate sin nx by n, so it will become minus cos nx by n, and already we have n over here, so it will become n square. And then after we have to integrate this function, that is minus cos nx by n square, so it will become minus sign will be as it is, and integration of cos nx, that will be sin nx by n, and already we have n square over here, so it will become n cube. And we have to keep alternate sign, start from plus sign, so plus, then after minus, and then after plus, and so on. And the limit is from 0 to 2 pi. Now if you will put down upper limit 2 pi first, so here you will get sin 2 n pi, and the value of sin 2 n pi is 0. Then after, if you put down the value of 2 pi over here, so it will become cos 2n pi, and the value of cos 2n pi is 1. And for this term sin 2n pi, so it will become 0. So the first term and the last term will become 0 for the upper limit 2 pi. Now for the lower limit, right, if you will replace x by 0 over here, so the first term will become 0. And then after for the second term, again here we have 2x, so it will become 0. And as you know, the value of sin 0 is 0, right? So this term will also become 0. So we will be having only one term for the upper limit 2 pi, and the remaining terms will be 0. So an equals to 1 over pi 4 pi cos 2n pi over n square, and sin 2n pi sin 0 both are 0. Now we will simplify this result, as all of you know that the value of cos 2n pi is 1. If you will replace n by 1, you will get cos 2 pi, and cos 2 pi is 1. And if you will replace n by 2, so you will get cos 4 pi, and again the value of cos 4 pi is 1. So in general, we have cosine of 2n pi equals to 1. Similarly, you can think about sin 2n pi. If you will replace n by 1, so it will become sin 2 pi, and the value of sin 2 pi is 0, and so on. Okay. So here we have 1 over pi into 4 pi, and this is 1, and divided by n square. So pi will cancel out, so the value of an is 4 upon n square. Now similarly, we will find out the value of dn, and dn is 1 upon l integration from c to c plus 2l f of x sin n pi x by l dx. Now in Bn we will replace L by pi, C by 0, and Fx by x square. So it will become 1 upon pi integration from 0 to 2 pi Fx, replacing L by pi, so it will become sin nx. Now we will replace Fx by x square. Now we have to integrate x square sin nx with respect to x. So again, we will apply Bernoulli formula, right? So x square will be as it is. Derivative of x square is 2x. Derivative of 2x is 2 because 2 is constant, and derivative of x is 1. Then after we have to integrate sin nx. Integration of sin nx, that is minus cos nx by n. Then after minus sign will be as it is. Integration of cos nx is sin nx by n, but already we have n over here, so it will become n square. And then after integration of sin nx, that is minus cos nx by n. So here already we have minus sign, so it will become positive. And already we have n square over here, and if you multiply n square by n, so it will become n cube. And you have to keep alternate sign, positive, then after negative, and then after positive. Now we have to simplify this result by keeping upper limit 2 pi and the lower limit 0. And for the first term cos 2n pi, the result is cos 2n pi is 1, right? So we will be having this first term, and if we will replace x by 2n pi, now if we replace x by 2 pi over here, so it will become sin 2n pi, and as you know the value of sin 2n pi is 0, so this term will become 0. And for the third term cos 2n pi, and that is 1, so for the upper limit 2 pi we will be having first term and the third term. Now for the lower limit x equals to 0, if we will put down the value of x equals to 0 over here, so it will become 0. Second term also will become 0, and for third term we will be having cos 0, and the value of cos 0 is 1. So total we will be having 3 terms, 2 for the upper limit 2 pi and 1 for the lower limit 0. So here it is 1 upon pi into bracket replacing x by 2 pi, and 2 pi square is 4 pi square, and after minus this one will become cos 2n pi divided by n. Then after this term will become 0, as the value of sin 2n pi is 0. Then after 2 will be as it is, and cos 2n pi, then after divided by n cube, and for lower limit 0, first and second term will become 0, and minus sign, then after 2, cos 0 divided by n cube. Now we have to simplify this result. This is 1 over pi. Value of cos 2n pi is 1. So minus 1 into 4 pi square, so it is minus 4 pi square divided by n. Value of cos 2n pi is 1. 1 into 2, 2. This one will become 2 upon n cube. Value of cos 0 is 1. So it will become minus 2 by n cube. So plus 2 by n cube and minus 2 by n cube will cancel out. Now we will simplify this result. You can see that pi one time will cancel out. The value of Bn is minus 4 pi upon n. Now we will find out the Fourier series of given function. Hence f of x equals to a0 by 2, right? Putting down the value of a0 and dividing it by 2. So we have 4 pi square by 3. Then after plus summation n is from 1 to infinite. This is cos nx and the value of an is 4 upon n square. So writing 4 outside. So we have 4 into summation n from 1 to infinite 1 over n square into cos nx, and the value of Bn is minus 4 pi over n. So writing 4 pi outside. So we have minus 4 pi into summation from n equals to 1 to infinite 1 over n into sin nx. So this is the Fourier series of the given function in the interval 0 to 2 pi. But we have to reduce this result also. So for that purpose, we will expand this series. Now replacing f of x by x square and remaining term will be as it is. Now say this is result number 1. So first of all, to reduce this result, we will put x equals to pi in this equation. So replacing x by pi, so left hand side we have pi square and that is equals to 4 pi square by 3, and value of sin n pi is 0. So this term will be eliminated, plus 4 sigma from n equals to 1 to infinite 1 over n square, and the value of cos n pi, that is minus 1 raised to n. You have to write down this reason. Value of sin n pi is 0 and cos n pi is minus 1 raised to n. Now pi square will be as it is. Now taking this term towards left hand side, so it will become pi square minus 4 pi square by 3, and that is equals to, now 4 will be as it is. Now replacing n by 1, so it will become minus 1 raised to 1, and that is minus 1, and divided by 1 square. Then after replacing n by 2, so it will become minus 1 square, and that is plus 1, and divided by 2 square. Then after replacing n by 3, so minus 1 raised to 3 is minus 1 and divided by 3 square and so on. Now we will simplify this result. So pi square minus 4 pi square by 3, it will become 3 pi square minus 4 pi square, so that is minus pi square, and divided by 3 and multiplying this 3 by this 4, so it will become minus pi square by 12, and that is equals to minus 1 upon 1 square plus 1 upon 2 square minus 1 upon 3 square and so on. Now we will multiply this expression by minus sign. So we have pi square by 12, that is equals to 1 upon 1 square minus 1 upon 2 square plus 1 upon 3 square and so on. So it will become pi square by 12, that is equals to 1 upon 1 square minus 1 upon 2 square plus 1 upon 3 square minus and so on. So this is the required result. So in this lecture we have discussed Dirichlet's conditions, whether we will be having a Fourier series of function of x or not. And then after we have discussed basic concepts, how to find out the Fourier series of given function f of x in the interval 0 to 2l, and we have seen one example related to this topic. Thank you for watching this video. I will see you in the next lecture.